that we were looking at before. And I'm going to open up an Excel spreadsheet. I'm going to make this a little bit bigger so it's easy for folks to see. Okay, and I'm dealing with the situation where I have, and again, I'll check the questions box every once in a while to see if anything's going on, but it's hard to watch that and work at the same time. So you have to be a little bit patient with me if I don't immediately see that that there's an issue or that you guys have a question or something like that. Okay, I'm going to start with a small data set. This small data set consists of values for 11 individuals. These might be heights, they might be blood pressures, might be blood sugars, who knows what they are, but they're just, for the time, they're numbers. Let's look at some of the basic statistics that we looked at, or the basic measures of how these numbers are spread, where the center of the numbers are, and so on and so forth that we looked at last week. That we're going to take a little bit closer look at them, and we're going to derive some of the values that we were talking about. Well, first of all, one of the first things we looked at in terms of these values is where the center is, where the middle is. Okay, well, first thing I'm going to do is I'm going to add these up. And as we learned in Excel, we have functions built into Excel where I can highlight these cells or select these cells and find the total for these particular cells. Now, I could use a function called count, or I could just use count, just so that we know it works. And we can see that there are 11 values here. So we have the sum of these values, we have the total number of values that there are, which is 11. And if we divide the sum by the sample size, the sum of x, sigma x, divided by n, that's our mean, or our average is 70. Another way I could have done that was just to say average, parentheses, and just take the average of this whole column. Okay, got the same number there. Okay, so now I need a way now to describe a little bit more about this. We kind of have an idea where the middle is. But now we want to know how spread out this is, how these numbers are distributed, how close to the mean they are, how far away from the mean, how extreme some of the values are. Okay, so what I'm going to do now is I'm going to say to myself, okay, well, 70 is the middle. Okay, how far away is each one of these individual values from the middle? In other words, what's the difference between each individual value x and the mean for the sample, x bar? Usually that's symbolized by x with a bar over the top of it. I'm just using the word because it's easier for me to display here. Okay, so I'm going to calculate that. That's going to be equal to 70 minus the mean, which is 70. Okay, there's no difference with that particular value in the mean. Now, I'm going to do that same calculation all the way down. And I know that if I do this with relative addressing, the way I would copy it down now, that it would take 75 minus, instead of x bar, it would drop down. Well, we get a 70 again because I put one there, right? But the next one, 67, would be 67 minus a blank space, right? So I have to change this to absolute addressing, as we discussed last week. Put a dollar sign in front of B and a dollar sign in front of the 15. And now, when I copy it down, it's only going to advance these numbers and keep subtracting 70 from it. So it makes things a lot better for us. Edit, and I can say fill down. Okay, then copy that formula down. I'm going to center that just to make it easier to see. I could have also just gone here and said fill down here as well. Both of them work the same way. You'll find in Excel there's a lot of ways to skin a cat. Okay, so now I'm going to add all these values up. I'm just going to pick a box down here, and I'm going to say, okay, well, if they're spread out, right, and these are the numbers, this is how far they all are from the mean. If I add up all the differences, that should be useful to me. Okay, anybody want to predict what I'm going to get here and type in the question box, what I'm going to predict when I hit enter and take the sum of all these values? What do you guys think I'm going to get there? Well, I got a 0, didn't I? Right? And I'm always going to get a 0 because that's basically the definition of the mean, which is the arithmetic average of all these numbers. So if I look at all the differences there, I add them all together, some are negative, some are positive, they're going to cancel each other out. Okay, so I have a couple of people that responded to that. Thanks. So that's not going to help me. So one of the ways that we can work with to get rid of negative numbers, to find positive values easily arithmetically, is to take these numbers and square them. Because if you multiply a negative times a negative, it becomes a positive. So I'm going to do exactly that. I'm going to square each one of these values. I'm just going to, square means just multiply it by itself. That's one way that I could do that. And I'm going to copy that down. I'll do it this way this time. fill down. I'll center that so we can see it. And you can see 25, 9, so on and so forth. This time, when I add them all together, I wind up with a number, 112. Now, of course, that number has been blown up by the fact that we've squared all these, but we're going to take care of that soon. Now, let's find the average. Now, this number is an important value to us. We give it, anytime we have an important value in statistics or math, we tend to give it a special name. This particular number is the difference, is the sum of the squares of the differences, or the sum of squares for short. That's an important value for us. Okay, so now that's the sum of all the differences. I'm going to find squares of all the differences. I'm going to find the average of that. I'm going to do something a little tricky right now that's not going to make much sense at the moment, but later on in the semester, as we work with this, there's going to be a reason for doing this. Instead of dividing by the sample size 11, I'm going to divide by 10, the sample size minus 1. That has something to do with a concept called degrees of freedom, which we'll learn about later on. But for the moment, just take my word for it. It's going to work out better if we divide by 10 instead of 11. Okay, that gives us 11.2. That 11.2, that number 11.2 is called the variance. Okay, and the variance is a special value. That now is in the range of these actual numbers, except for the fact that we squared all these numbers, right? We did divide by 10 to take advantage to bring this back into an order of magnitude that involves a difference for each average difference for each individual value, but we still squared it. So now, in order to work with this and have something that's still in the range of these numbers, or that'll make more sense to us, we're going to take the square root of that. Okay, and the square root of that variance that we just calculated has a special name also, because it has special meaning for us. It's called the standard deviation. That's going to be very important to us as we work through this semester. As we use SPSS and some other programs, we're going to be calculating these values very quickly. But I just wanted to go use Excel as a tool to show you how we derive these, where these numbers came from, that we didn't just make this stuff up, and that there is a way to actually calculate this stuff for yourself. Okay, so we have the mean, we have the variance, and we have the standard deviation, important concepts that imply for us the middle and the variability in these values. The more the variability, the bigger the differences, the bigger the squares of the differences, the bigger the variance in the standard deviation. The less the variability from the mean, the smaller all these numbers are. Now, in addition to that, I'm going to look at something else here as well. I'm going to take these numbers. I'm going to move this over because you guys can probably see it pretty well there. It's a little added. There's a couple of things on my desktop that are in the way. I'm going to take these numbers. I'm going to copy them over here. Edit. I'm going to copy. I'm going to click in here and say paste. Okay. And here are those 10 numbers just pasted in another location. They're still selected. While they're still selected, I'm going to do something special with them. I'm going to go up to data and tell SPSS to sort these values for me. Now it's asking me, it's these other columns here, and I'm telling it I only want it to sort the current selection. I don't want to sort all this other stuff with it. I just want these 10 numbers to be sorted. Okay, it's sorted. It's rearranged these 10 numbers so that the smallest numbers at the top, largest numbers at the bottom. Well, there's 11 numbers here, right? The middle number is the sixth number from either direction. Let's see, 2, 4, 5, 70, and there's 5 here. So 70 is the middle number. That's our median. I'm going to highlight that number. Okay, let's see if it works out this way if I use my function to find that number. The median of these numbers is 7, just as I can see visually. Now, one of the ways that we like to identify the position of a number in a sorted sequence is by describing its percentile rank. You guys know when you took the GREs, when you took the SATs, that you wound up with not only a numerical score, but they also gave you a percentile. Now, you guys are smart guys, so you guys were probably all in the 90s, and in your GREs, it would say let's say your score is 780, and you're in the 94th percentile. Okay, that means that 94% of the scores are below you, 6% of the scores are above you. We can do that basically with any set of sorted numbers. Okay, so for instance, if I looked at this and I looked at where the mean is, well, the mean represents the 50th percentile. 50% of the scores are above it, 50% of the scores are below it. If I look at just the 50% of the scores that are below it, of those 50% of the scores that are below it, one of those values is in the middle, right? Well, the middle of a series where 50% is below it, that value is going to be the 25th percentile, right? And similarly, if I look at the values that are above it, well, that middle value is going to be the 75th percentile. Okay, I can actually calculate that here. There's a function in Excel called percentile, parentheses. I spelled it wrong. Percentile, parentheses. And he asked me for the array and a value k. Had I gone up to function and found it in the function file, it would explain to me that k was the percentile as a proportion. Okay, so I'm going to say, okay, this is the array. These are the numbers, comma, and I'm looking for the 25th percentile, so that would be 0.25. Another way of describing the 25th percentile is to say the lower quarter or the lower quartile. Okay, similarly, 73 was our upper quartile, okay, or our top 25%. Okay, let's give that a try. Equals percentile, parentheses, and I'm going to look at the array here, comma, 0.75 or 75th percentile. And sure enough, that's where I am with 75th percentile, 73. Now, if I look at this, the middle values, the middle 50% of values are between the lower quartile and the upper quartile, between the 25th percentile and the 75th percentile. Right here represent 75% of our values. 50% of the middle 50% of our values. We give that a special name. We call that the interquartile range. I have abbreviated that as IQR for our purposes here. Okay, interquartile range. That's going to come up as well. So here's some handy ways that we were able to use Excel to calculate these things that we're going to find much more efficient ways to do later on, but perhaps not as transparent, not as easy to understand as what's going on here. Okay, so now I'm going to move over to SPSS. And I'm going to take SPS. Before I do that, I'm going to open up another Excel data file. Here's an Excel data file that has 3 columns in it. Okay,